Here is question number 4, which is second to last question in part A. We're asked to find the inverse of this matrix A and hence use the result to solve this particular equation. First of all, let us find the inverse of this matrix. Inverse of this matrix is denoted by A inverse, which is simply equal to 1 divided by the determinant of the matrix A multiplied by the adjoint of this matrix A. So let us go ahead and find two things. Find the determinant, take the reciprocal and multiply by the adjoint of the same matrix. So let's start with the determinant. The determinant is denoted by this, which is equal to, our inputs are 3, 4, 5, and 2. 3, 4, 5, and 2. To find the determinant, we are going to first of all multiply the leading diagonal. The leading diagonals, we have 3 multiplied by 2. Then we subtract the other product, which is 5 multiplied by 4. And this is equal to 6 minus 20. And this is equal to negative 14. So negative 14 is the determinant of this matrix. Now, what about the adjoint? To find the adjoint of this matrix, we have A, which is given as 3, 4, 5, and 2. If you want to find the adjoint of A, ADJ of A, finding the adjoint of 2 by 2 matrix is very simple. All you have to do is to interchange the leading diagonals. Let us interchange them. We have 2 and 3. Then the rest of the diagonals, we are going to multiply them by negative 1. So we have negative 4 and negative 5. So this is the adjoint of our matrix. But remember, the formula remains A inverse equal to 1 divided by the determinant multiplied by the adjoint of the matrix A. So let's substitute. This is equal to 1 divided by our determinant, remember, is negative 14. So we have negative 14 here, multiplied by the adjoint, which is 2, negative 4, negative 5, then 3. This is a scalar multiplying a matrix. So now we are going to multiply every single element by this scalar, 1 divided by negative 14. So this is going to be 2 multiplied by that is going to give us negative 1 divided by 7, because 2 can go into 14 7 times. Negative will transform that to positive. So we have 4 divided by 14, which is going to give us 2 divided by 7. Then the bottom, we have negative cancel. We have 5 divided by 14. And the other one, we have negative 3 divided by 14. So this is the inverse of our matrix. And we are going to use it in order to find a solution to this problem. We're asked to solve this simultaneous linear equation. So let me just copy the equation. You can see the coefficients are exactly what we have in our matrix. We have 3, 4, 5, and 2. The only constants are what is missing. First of all, we are going to form a matrix of the coefficient of these two equations. So we have 3, 4, 5, and 2. Then we multiplied by x and y. This will be equal to the matrix of the constants 1 and 3. If you multiply this, you're going to obtain this back, definitely. So we are going to name this matrix. Let me call this one matrix A. Let me call this matrix B. Let me call this matrix C. If you observe, by multiplying A by B, we are going to obtain C, where B is the values of x and y. Remember, since we are looking for the values of x and y, we are going to make B the subject. So we are going to multiply both sides by A inverse, because A inverse will cancel A. So A inverse multiplied by AB is the same thing as A inverse multiplied by C. A inverse will cancel A, so we have B equal to A inverse multiplied by C. Already we have our A inverse here. All we have to do is to multiply that with the constants. So let me copy this. So this is the A inverse, and the constants we have 1 and 3. So let me multiply this with 1 and 3. So remember, this is B, which stands for the values of X and Y. So we are going to take this first row and multiply by the first column here. Already we have only single column. It is going to be negative 1 divided by 7 multiplied by 1, right? Then plus 2 divided by 7 multiplied by 3. This is what we have. Then the other one, we take this and multiply by 1. We have 5 divided by 14 multiplied by 1. Then we add negative 3 divided by 14 multiplied by 3. This is our new matrix, which stands for B, and B, you know, is a point X and Y. So now let us simplify. To the top, we have negative 1 divided by 7 times 1 is still negative 1 divided by 7. We added 2. 2 multiplied by 3 divided by 7 is 6 divided by 7. To the bottom, we have 5 divided by 4. Then we added 2. This becomes negative 9 divided by 14. We are still simplifying. This is our X and Y values. To the top, we have negative 1 over 7 plus 6 over 7, which is the same thing as 5 over 7. So we have 5 divided by 7. To the bottom, oh, this is 14, sorry. This should be 14. We have 5 divided by 14 minus 9 divided by 14, and that will give us negative 4 divided by 14. And negative 4 divided by 14 will give us negative 2 over 7. So we have negative 2 over 7. Remember that this is equal to B, which stands for the values of X and Y. Therefore, finally, you can clearly see that X, Y, which we are looking for, are nothing but 5 over 7 and negative 2 over 7. So this is the solution to this system of linear equations, which we have used the inverse of our original matrix A to find the values of X and Y. Now let us move on to the last question in section A, which is question number 5.